really the intention of tonight is to talk about reality and what it means, what this concept means of reality. So we'll begin with this concept of unreal into reality. Particularly, we'll use general relativity and quantum physics. And we'll just sort of speak of the foundations of some of these concepts, some of these theories, and look at the insights they provide of what it means to speak of reality and our perception of it. So there's a canvas of space-time. In the time of Newton, space was a thing with which carried all of the action. So it was like a background. And with general relativity, space and time are intertangled, and gravity affects both of it. So it's as if the canvas became part of the story. Yes. So we spoke last time of this equation, this Einstein's field equation. The right side is the time or energy and mass tensor, which describes a mass or a source of energy. The left side talks about how space and time is affected by the mass or energy. In particular, there's three concepts which are the foundation of general relativity. A concept called locality, another one called causality, and determination. And I'll talk about what each of these things mean. So, locality, or local realism in particular, it means that an event at one point cannot simultaneously cause an event somewhere else. So there has to be cause and effect. This is sort of how we perceive reality. This is how things happen. And if there is a cause over here, the effect cannot happen faster than the speed of light. So if something happens here, it can create an effect further away, but that effect can't happen faster than the speed of light can travel. And the concept of realism means that the universe or nature exists even if we don't know that it's there. Babies, for example, don't really get this, we think, because this game we call peekaboo in English, Kuckuck in Deutsch. You hide yourself and reveal yourself, and the baby thinks that's really funny because you're gone and then you're back. So this is, as we develop our brains, we perceive realism a little differently. So even though I hide my face, you know I'm still there. If I leave the room, you presume I'm still there. And this is a fundamental concept that's part of the theory of relativity. Causality, we have here a tool, it's called a light cone. This square here, if we imagine that we live in 2 dimensions, just for this example, if some event happens here at this point, and we're watching over here at this eye, we cannot see immediately what's happened because the information has to travel to us. And what these cones mean is that if information travels at the speed of light, this arrow indicates the movement of time. At some later time, this information has been able to travel so that we can observe it in the future. And likewise, there's a past time cone as well, we'll talk about a little bit later. But the information that can be shared is limited to what happens in time inside of this cone of time. So this is just a way to talk about cause and effect and how information travels. So determinism means if we know exactly what's happening to a thing, say a particle, right now, it means we can determine the future path of this particle. This is a big part of physics, to be able to predict what's going to happen in the future, to determine the future. And in general relativity, this fact of determinism works pretty well throughout the whole theory. There's some extreme cases, for example, next to a charged black hole, But generally, using relativity, if we know what's happening now precisely, we can predict what will happen in the future, and it works. So far, relativity is sort of a nice, clear, sort of fits in with our concepts of reality. So confusion or clarity. So the foundation of general relativity, more or less, agrees with how we perceive reality. And this is a great quote by somebody named Adam Becker. He said, quantum physics, it's the most successful theory in all of science. And quantum physics doesn't seem to apply to humans at all. So quantum physics is the reason all of this technology we're using tonight exists. We use it all the time in every aspect, from our cars to our phones. It works. Quantum physics works. It can predict what happens in experiments, but on a fundamental level, it seems counterintuitive and sometimes in complete contradiction to what we perceive as reality.